Students, let's do playing with numbers exercise 3.5, and in this exercise we're going to look into factor trees and prime factorization. Question 1. Here are two different factor trees for 60. Write the missing numbers. So we have the first one shown here. So this is a factor tree. Now what is a factor tree? It's a way of breaking down any number, in this case it's 60, into its prime factors. Now each branch, now this is a branch. Can you see the arrowhead marks are the branches? So each branch is split into factors. You get factors. And this goes on. And when does this branch stop? The branches stop when we end with prime numbers. When the last part is a prime number, at the end of the branch, if you have a prime number, then we stop with that. So here we have 60. As you can see, it is broken down into 6 into 10. 6 tens are 60. Now 6 is again broken down into 2 into what? That is a question. So we need to write the answer there. 2 into what will give us 6? 2 threes are 6. So the answer in this circle here is 3. So what are the prime factors of 6 here? 2 and 6. Then here we have 5. As you can see, 10 is broken down again into 5 and what? 5 twos are 10. So this is equal to 2. So we've got our answer to the first one. The first missing number is 3 and the second missing number is 2. So now the branch has stopped, and as you can see, the end of the branch here is 2 and 3, which are prime numbers. Beside the end is 5 and 2, which are once again prime numbers. So at the end of the branch, you will have prime numbers telling us that the branch will not continue further. So this is a factor tree for 60. Now we have another factor tree for 60 done in a different way. Okay, so here it's broken down into 30 into what? 30 into what is 60? 30 into 2. So we've got the answer to the first question mark. 30 into 2 is 60. Now 2 is already a prime number, so this branch will not continue. Whereas this branch is continuing. 30 is 10 into what? 10 into what will give us 30? 10 threes are 30, isn't it? So here we've got the answer. This is 3. Now 3 is also a prime number. So this part of the branch will stop here. Whereas this part is a composite number. It's again going to be broken down here. Now 10, here they've given 10. What into what will give us 10? Now 2 5s are 10, isn't it? So here you can write 2 and here we get 5. So we have come to the end of the branches, and at the end of the branches what do we have? We have 2, 5, 3 and 2. They're all prime numbers. Now question 2. Which factors are not included in the prime factorization of a composite number? Now prime factorization of a number, that means you divide a number using prime numbers. Now let me take the composite number 10. Okay, now let's divide this using prime numbers. 2 5s are 10 and then again we have 5 1s are 5. Now what are the prime factors of 10? 10 is a composite number. What are the prime factors of 10? 2 and 5. Now let me take another example. Now let's take 12. 12 is also a composite number, isn't it? Now let's use prime numbers to get all the factors. 2 6s are 12, then 2 3s are 6, then 3 1s are 3. So prime factorization, what do you get? You get 2 into 2 into 3. The prime factors are 2 and 3. Okay, here for 10 the prime factors are 2 and 5. For 12 the prime factors are 2 and 3. Now 10 and 12 are composite numbers. Now what does the question say? Which factors are not included in the prime factorization of a composite number? Now these are composite numbers 10 and 12. As you can see, the factors of 10 do not include 10 and 1. And the factors of 12 do not include 12 or 1. So what are the factors that are not included in the prime factorization of a composite number? The number 1 and the number itself. Okay. So let's get the answer. The factors that are not included in the prime factorization of a composite number are 1 and the number itself. Question 3. Write the greatest 4-digit number and express it in terms of its prime factors. So there are two parts to this question. We have to write the greatest four-digit number first. So this is the first part of the question. First, we have to write the greatest four-digit number and then write its prime factors. So now, which is the greatest four-digit number? Okay, which is the greatest one-digit number? 9. The greatest two-digit number? 99. Greatest three-digit number? 999. So the greatest four-digit will be 9999. That's 9999. So the greatest four-digit number is 9999. Now our question is express this part, this number in terms of its prime factors. So let's do that. So we've got 9999 here and we are going to divide this using a prime number. As you can see, since it's ending in 9, which is an odd number, it is not divisible by 2. But this will be divisible by 3. Now how do we know it? If you add up all 4 nines. Okay, so 4 nines are 36 and 36 is divisible by 3. So let's divide this by 3 and see what we get. So 3 threes are 9, 3 threes are 9, 3 threes are 9, 3 threes are 9. Now let's just divide this again by 3. 3 ones are 3, 3 ones are 3, 3 ones are 3 and 3 ones are 3. So now what do we have here? Here we have 1111 and we need to divide this using a prime number. Now let's see whether it's divisible by 3 by adding all these. 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 is 4. It's not divisible by 3. Now what are the other prime numbers? Think of all the prime numbers: 2, 3, 5, 7, 11, 13 and so on. Now it's not divisible by 2. It's not divisible by 3. It's not divisible by 5 because it's not ending in 0. Now, is it divisible by 7? We can try that. Let's divide it by 7 and see. So we have 1111. Now, is this divisible by 7? 7 ones are 7 minus we have 41. Now 7 fives are 35. So that is 7 fives are 35 minus. So here we borrow 11 minus 5 is 6, 61. No, 7 nines are 63, 7 eights are 56. So this is not divisible by 7. So it's not divisible by 2, 3, 5, 7. Is it divisible by 11? Okay, let's try that. So 1111. Is this divisible by 11? Let's see. So the first number is small, so we take 11. 11 ones are 11 minus 0. We bring down the next number. It's 0. Bring down one more. 11. 11 ones are 11 minus 0. Yes, the remainder is 0. That means 11 into 101 will give us this number. So let's write it down there. So this time we are dividing it by 11 and we get 101. And 101 is a prime number. So we divide it by 101 itself. So we get 1. So now we have all the prime factors. What are all the prime factors of 9999? Now we have 3 into 3 into 11 into 101. So the prime factors of the greatest four-digit number 9999 will be 3 into 3 into 11 into 101. Question 4. Write the smallest five-digit number and express it in the form of its prime factors. So again, we have two parts here. First, we have to write the smallest five-digit number and then write its prime factors. Now, the smallest two-digit number. Okay, let's start with the smallest two-digit number. That's 10. Three-digit number will be 100. Smallest three-digit number. Four-digit 1, 2, 3, 4. That is 1 followed by 3 zeros. So 5-digit number will be 1 followed by 4 zeros. 1, 2, 3, 4. So let me go through this again. Smallest two-digit number is 1 followed by 1 zero. 10. Two-digit number. Okay. So this is the smallest two-digit number. The smallest three-digit number is 1 followed by 2 zeros. So this is the smallest three-digit number. Then the smallest four-digit number is 1 followed by 3 zeros. So that is the smallest 4-digit number. Now we've been asked to write the smallest 5-digit number, that is 1 followed by 4 zeros. So this is the smallest 5-digit number, and what number is this? 10,000. So the smallest 5-digit number is 10,000. The next part of the question is we have to write its prime factors. So just like we did for the previous one, let's take the number 10,000 and start using prime numbers to divide it to find the prime factors. So let's begin. 10,000, we have taken 10,000 and we're going to divide it by 5. Let's try with 5 because it's ending in 0, isn't it? It's easier. Now 10, 5 twos are 10. Now there are 1, 2, 3 more zeros. Let's write it. You can continue again with 5 because 5 is still a prime number. Let's take the first 2 digits 20. 5 fours are 20, then 2 more zeros. Continue again with 5. We are using only prime numbers, remember that. Now let's take 40. 5 eights are 40 and a 0. Since it's ending in 0, we can still use 5. 5 ones are 5, but that number is 8, isn't it? 5 ones are 5, 6, 7, 8. There is 3 left. So the number is 30 now. 5 sixes are 30. So now we've got 16. You can't use 5 anymore. We can use 2 because it's a prime number. 2 eights are 16. Now continue. I can use 2 again. 2 fours are 8. Again I can use 2. 2 twos are 4. Once more 2. 2 ones are 2. That's it. So we've got all our prime factors. What are they? 5 into 5 into 5 into 5. So there are 4 5s into 2 into 2 into 2 into 2. So we have 4 5s and 4 2s. So let's write down our prime factors of 10,000. Prime factors of 10,000, we'll start with the smallest number, that is 2. There are 4 2s, 1, 2, 3, 4, and then 5, we have 4 5s, 1, 2, 3 and 4. So these are all the prime factors of the smallest 5-digit number, that is 10,000. Question 5. Find all the prime factors of 1,729 and arrange them in ascending order. Okay, so first part is find all the prime factors, then arrange them in ascending order from small to big. Now state the relation, if any, between two consecutive prime factors. Okay, so there are 3 parts, children. Be careful when you read your question. Find all the prime factors of this number, arrange them in ascending order, and see if there's any relation between 2 consecutive prime factors. So let's begin with the first part, prime factors of 1,729. So we have the number 1,729. Now we are going to use prime numbers to find the prime factors of 1,729 by division. Now we need to do the different tests. Okay, now what are all the prime numbers? Let's write down a few prime numbers. 2, 3, 5, 7, 11. We'll stop with this and then we'll go ahead and see some more. Now, is this number divisible by 2? The last digit or the digit in the ones place should be an even number, and 9 is not an even number. That means this is not divisible by 2. Is it divisible by 3? What is the test for 3? We have to add up these digits. So let's add up 1 plus 7 plus 2 plus 9. 1 plus 7 is 8. 8 plus 2 is 10. 10 plus 9 is 19. And 19 is not there in the tables of 3. So it's not divisible by 3 also. So let's take off 3. Then let's go to 5. Is it divisible by 5? The ones place, the digit should be 0 or 5. Only then it's divisible by 5. That means this number is not divisible by 5 also. So take away 5. Now the next prime number is 7. So let's divide this number by 7 and see whether it's divisible. That means the remainder should be 0. 1,729. Let's divide this by 7 and see. 7 twos are 14 minus 7 minus 4 is 3, 32. Now 7 fours are 28 minus, again when you borrow you get 12 minus 8 is 4. You bring down 9. So now 7 sevens are 49. 7 sevens are 49 and our remainder is 0. That means 1729 is divisible by 7. That is 7 into 247. So let's write that. So the first number, prime number that we're taking is 7, and we've got 247. Now look at 247. Is 247 divisible by any of these prime numbers? Let's try that again. So as you can see, it is not divisible by 2. So let's strike that off. It's not divisible by 2. Is it divisible by 3? Let's add it up and see. 2 plus 4 plus 7. 2 plus 4 is 6. 6 plus 7 is 13. That means it's not divisible by 3. Is it divisible by 5? No, because the last digit is not ending in 0. Is it divisible by 7? Let's divide it and see. 247 divided by 7. Let's take 24. 7 threes are 21. Minus 4 minus 1 is 3 and 0. We bring down 7. Now we have the number 37. 7 fives are 35 minus 2. The remainder is not 0. That means this number is not divisible by 7 also. Now the next prime number is 11. So is it divisible by 11? Since it's a small number, you can actually do the division. Now 11 twos are 22. Minus 4 minus 2 is 2. 27. Again 11 twos are 22. Minus 7 minus 2 is 5. The remainder is not 0. It's not divisible by 11 also. Now what do we do? Let's take the next prime number after 11, that is 13. 11, 13. Now let's divide 247 by 13 and see. 13 ones are 13, 13 twos are 26. So I can only write 13 ones are 13. Minus 4 minus 3 is 1. 2 minus 1 is 1. We bring down 7. Since it's ending in 7 and we have 3, let's try 13 into 9. 9 threes are 27, carry 2. 9 ones are 9, 10, 11. Okay, so 13 into 9 is 117. And our remainder is 0. That means this is divisible by 13. 13 into 19. So let's divide 247 by 13. 13 into 19 is 247. Now our number is 19 and 19 itself is a prime number. So it's divisible by 19. So 19 ones are 19. So we've got all our prime factors of 1729. So the prime factors of 1729 are 7, 13 and 19. Okay, so we found the first part. So let's write that, and it says arrange them in ascending order. So we start with the smallest number 7, then we put 13 and then we put 19. So they are 7 into 13 into 19. Now we've also been asked another question. Now we have been asked to state the relation, if any, between two consecutive prime factors. So these are the three prime factors. They're asking us to take two consecutive ones. That means I should take 7 and 13 and 13 and 19 and to see if there's any relation between them. What do you think the relation can be? Now if we take 7 and 13, now if you minus 13 minus 7, what do we get? 13 minus 7 is 6. Now let's take the other two numbers. So first we took 7 and 13 because they said take two consecutive numbers. Now let's take 13 and 19 and try the same thing. 19 minus 13 is also 6. So can you see the relation? The relation between two consecutive prime factors is 6. So let's write down that answer. The difference between two consecutive prime factors here is 6. So we have answered all questions. We have found the prime factors of 1729. Then we arranged them in ascending order from small to big. And now we stated the relation between two consecutive numbers. And what is the relation? The difference between two consecutive prime factors is 6. Question 6. The product of three consecutive numbers is always divisible by 6. Now, a statement is given to us that the product, that means the answer that you get when you multiply, what should you multiply? Three consecutive numbers, any three consecutive numbers. When you multiply, the answer is always divisible by 6 is what the statement says. Now we have to verify the statement with the help of some examples to see whether it's true or not. So the product of three consecutive numbers is always divisible by 6. This is a statement given to us and we are going to verify this with the help of some examples. Now let's take some numbers. Okay, let's take from the beginning itself to make it easy for us. So 2, 3, 4, 5, 6, 7 and so on. Now let's take three consecutive numbers. That means numbers that come one after the other. 2, 3 and 4. Shall we take 2, 3 and 4? Okay. And we have to find the product means we should multiply 2 into 3 into 4. So let's multiply these three numbers. 2 threes are 6, 6 fours are 24. And the statement says this product will be divisible by 6. Is 24 divisible by 6? Yes, 6 fours are 24, isn't it? 6 fours are 24. So 24 is divisible by 6 and hence we have verified the statement to be true. So this statement is true. Now let's take another example. So here first what did we do? We took 2, 3 and 4. Now let's take the next three numbers 5, 6 and 7. Okay, so let's do that. So 5 into 6 into 7. Let's multiply. 5 6 are 30. 30 into 7 is how much? Now 30 into 7, let's multiply and see. 7 zeros are 0, 7 threes are 21, 210. Now is 210 divisible by 6? Let's divide that and see. So we're going to divide 210 by 6. 6 twos are 12, 6 threes are 18 minus 1, 11. 11 minus 8 is 3. You bring down 0, 30. 6 fives are 30. So minus 0. So we've got 35 and the remainder is 0. That means 210 is also divisible by 6. So let's write that. 210 is divisible by 6. Hence, this is also verified. Now children, you take any three consecutive numbers, you multiply and you will find that the product is divisible by 6. So in this case, we have taken two examples and we have verified. We took 2, 3 and 4 and then we took 5, 6 and 7. These are three consecutive numbers each and we found that the product or the answer after you multiply is divisible by 6. So we have verified this statement. Now we will stop with this for now. In our next video, we will continue with the remaining questions. Thank you, children.